clock. So if it completes one revolution, that means that it's completing 1 hour. It's nothing but 60 minutes. So it's complete one revolution. Starts from 12 and ends with the 12. So it is 60 minutes. So if it is making 60 minutes in 360 degrees, because of that it's complete one revolution. So one revolution in a circle, it makes an angle of 360 degrees. So what we understood here is nothing but 60 minutes. This makes an angle of 360 degrees of minutes hand. So let's write 60 minutes is equals to 360 degrees, and minutes hand, this is the minutes hand. So minutes hand is making an angle of 360 degrees in 60 minutes. So let's divide this by 60 on both the sides. So this is 60 minutes. It's making an angle of 360 degrees. So let's divide by 60 on both the sides. So when we divide by 60, so this 60 get cancelled. Then 1 minute is equals to, it cancels. Then 6 times it cancels. So 1 minute makes an angle of 6 degrees. So let's recall. Minutes hand is rotating in a clock. So it makes an angle of 360 degrees in 60 minutes, because one complete revolution, it is 1 hour, we know that. So 1 hour is nothing but 60 minutes. 60 minutes is 360 degrees. Then so we divide it with 60 on both the sides to get 1 minute. So divide by 60 and divide by 60. So 1 minute is making an angle of 6 degrees in minute hand. So minutes hand make 6 degrees in 1 minute. So let's discuss about hours hand and a clock. In hours hand in a clock, if it's completing one revolution, it's nothing but it is 12 hours, because if it starts from 12 and complete one revolution and comes again to the 12, it's nothing but 12 hours. So minutes hand in 12 hours, it makes an angle of 360 degrees because it's completing 1 hour. So minutes hand will make an angle of 360 degrees in 12 hours. So let's write about the let's recall about the clock. In a clock, hours hand is completing one revolution, like it starts from 12 and complete one revolution to the 12. So it's 12 hours. Hours hand will make an angle of 360 degrees in 12 hours. So it starts from 12 and complete one revolution to the same point. It's that one complete revolution, and that is 12 hours. It makes an angle of 360 degrees. So hours hand in 12 hours, it makes an angle of 360 degrees. We have discussed. So here 12 hours, this is 12 hours, 360 degrees. So let's divide with 12 on both the sides to get in 1 hour. divided by 12, divided by 12. So after divided by 12, we'll be getting 1 hour here. So we cancel 12 on both the sides, numerator and denominator, we get 1. So 1 hour 30 degrees. So what we understood here is an clock, our hand is making an angle of 30 degrees and 1 hour is making an angle of 30 degrees. So let's find out in 1 minute how much angle it makes. So to get in 1 minute, we need to have here minutes. So let's change this hour into minutes. 1 hour is nothing but 60 minutes. So write 60 minutes is 30 degrees. In 60 minutes, it's making an angle of 30 degrees. So let's divide by 60 on both the sides to get how much angle it made by it in 1 minute. So divide with 60 by 60. So when we cancel the 60 and 60, we get 1 minute. 1 minute is 0, 0 get cancelled. 3 by 6 is nothing but half, 1 by 2. So what we understood from this, it makes an angle of half degree in 1 minute, because here we cancel all. In 1 hour, it's making an angle of 30 degrees. In 12 hours, it's making an angle of 360 degrees, and 1 hour it makes an angle of 30 degrees, and 1 minute it makes an angle of half degree. So let's write again. Hour's hand will make an angle of 30 degrees in 1 hour. 30 degrees it makes an angle of 30 degrees in 1 hour, and 1 minute it makes an angle of half degree. An arc of a circle is of length 5 pi centimeters. An arc of a circle is length of 5 pi centimeters, and the sector it bounds has an area of 20 pi centimeters square. Then find the radius of the circle. It's given that arc of the circle length of 5 pi centimeters. So there is sum of the arc of circle, it is 5 pi centimeters. What of the arc? As we have taken an arc, this is the arc, AB is an arc, it is 5 pi centimeters, and the sector bounds has an area of 20 pi centimeters square. Then this arc is bounding, it is making area of 20 pi centimeters square. So this is, it has an area of, it's making a sector. So this arc is making sector, an angle with an angle, and the radian with the 2 radian. So its area is 25 centimeters square. So let's find out the radius of the circle. Let's find out the radius of the center. So we know that the length of an arc is L is equals to theta by 360 into 2 pi r. So L is equals to theta by 360 into pi. R, we know that R. So 2 pi R, then length of an arc is, we know that, at least 5 pi theta by 360 into 2 pi R. So this is first one. We have taken L is equals to 3x pi theta by 360 into 2 pi R. Let's take this one as equation 1. The next one is area is equals to theta by 360 into pi r square. So here area is given 20 pi. So 20 pi is equals to theta by 360 into pi r square. This is the equation 2. So to find out r in this, let's divide equation 2 divided by 1. So equation 2 is nothing but 20 pi by equation 1 is 5 pi is equals to theta by 360 into pi r square. Theta by 360 into pi r square whole divided by theta by 360 into 2 pi r. So let's cancel. This pi is get cancelled. This will be cancelled in this 4 times. So 4 is equals to theta by 360. Theta by 360 is cancelled. Then pi and pi is cancelled. And one of the r in this and r is cancelled. Then remaining is r by 2. So let's find out r, and we transpose this 4 into 2, it becomes r. So r is equals to 8 centimeters. So finally we got the radius of the circle is 8 centimeters. It's nothing but the radius of the and sector also. Then this problem also we can find out in other method, that is we can use the formula of A is equals to half into length of an arc into radius. It's nothing but half of the product of the length of an arc into radius. So the relation between area and length of an arc is A is equals to half into LR. L is nothing but length of an arc and R is radius of the circle. So let's see here. We are finding this same problem using in another method. We can use this formula to find out the length of the radius of the circle. So here length of an arc is 5 centimeters and area of sector is 20 pi. So 20 pi is equals to half into L is nothing but length of an arc, that is 5 pi. So 5 pi into R. So here let's find out R in this. So 20 pi is equals to the numerator, it is numerator part, so 5 pi R divided by 2. We can cancel pi on both the sides. This 5 pi is get cancelled. So let's transpose this 5 by 2 to right hand side. 20 into 2 by 5 is equals to R. So let's cancel with 5 table 1 time 4 times. So 4 into 2 is equals to R. R is equals to 8 centimeters. So this is the radius of the circle we have found.